Going on, guys? In this video we are going to take a look at multiplexer. We also call this one as data selector as well. Data selector. Okay, let's look at an example of multiplexer. This is a generic form of multiplexer. Multiplexer to look like this. Okay, here for example I'm just drawing like a box. So here this is number of input ratio 1. It's always like that. It depends on the number of inputs depends on the select bit selector. Like if you have one select line, the number of input is 2 power 1. 1 is the minimum, so 2 power 1. So you're going to have 2 input, and if the select line is 2, then 2 power 2, you're going to have 4 input, but the output is always 1. But here we have output. This is single line. Okay, so let's say we have select lines S0 and then Sn-1. That's the maximum number of select lines we are going to have. Like for example, if the number of input is 2, this is 2 minus yeah, it's going to go till S0, S1, and then input is going to be I0, I1, and then In-1. Select lines. Sound. Select lines. Number of select lines. Select lines. N is number of inputs. Okay, so this is the generic term. Like you have to just know if we have input amount of if it's n should be the minimum, n should be 1. No, like it's not 1. If the select line should be the minimum 1. So it depends on the select line. Like if the select line is 1, then 2 power 1 is the input, that's going to be 2. Then if the select line is 2, then 2 power 2, that's going to be 4 input. Like that. You have to look at that. Now here we are going to look at a 2 by 1 mux. Let's look at that. 2 by 1 mux is 2 inputs. So we are going to have input of I0 and I1. And the select line should be just 1, because if it's 1 only, we get 2 inputs. 2 power 1, that's 2. So this is S0, and the output is always 1. Output, and N is number of input, that is 2 here. And if you want to find out select lines, let's say the input is 2, like input is 2, but they don't give the number of select lines. You can always find out that one using this formula. 2 power m is equal to n, therefore 2 power m is 2 input in this case, therefore 2 power m is equal to 2 power 1, therefore m is equal to 1. So this is helpful if you have like a lot of inputs and you want to find out how many select lines you have and it's not given, then you can use this formula to find it. Okay. Now let's look at the truth table for the multiplexer. So this is for the 2 by 1 multiplexer. S0 is the select lines, and then Y is the output. Okay, so whenever S0 is 0, it's going to be turned off. So the output is going to give is I0. It's going to select the first one, and then 1 is turned on, and then it's going to select the I1. Okay, so based on the select line input, it's going to select the input and give the output for it. Okay, now let's look at the expression for this. The expression for this output is going to be S0 naught and I naught, because it's 0 at this point. So to find the minterm, we put a naught for zeros. So S0 naught plus I naught, and then S0 I1. Now based on this, we can plot the diagram using logic gates, and here you can see this is S0 line, and if you connect node to it, you're gonna have two AND gates. This is S0 line, two AND gates. One of them is gonna connect with S0 naught and then I naught, and the other one is connected with S0 directly and then I1, and then both of them are all together, and the output is going to be Y. So this is S0 naught and this one is S0, and the output here is S0 naught I naught, and this one is S0 I naught. And for example, let's say the input is 0, then if the select line input is 0, then you can see this one become 1, because with there's a NOT gate, this will change. Like if it's 0, it's going to turn into 1. If it's 1, it's going to turn into 0. It's going to invert whatever the input we put. So this is going to be 1 and I naught. So we know the in AND gate, if you have 1 and the other one is something else, then whatever with the 1 is going to be the output. So I naught will be the output if we input 0. And here if the input is 0, this is going to be 0 and I1. Then we know that in AND gate, if we have 1 0, that's going to turn the whole thing into 0. So there's no output coming from this. So that's why this I naught is the output we are going to get at the end when the input is 0. If the S naught is 1 input, then this is going to turn into 0. So 0 with AND gate, that's going to make the whole thing into 0. So this is going to switch. This is not going to work. So this is going to go here, 1 and I1. And if you have an AND gate with 1 and anything else, the I1 is going to be the output. So I1 is going to go here, and that's going to be the final output. And that's how the multiplexer works. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.